we're going to talk about inequalities again. And we're going to begin with question number 3. So this is 1.6, your homework. And again, I always have time for questions out of the homework. We're going to start with question 3. Now, we need to remember also the difference between an and an or. Now, remember the definitions from last time. And is called an intersection. And that's going to be where they overlap. All right, so and is an intersection, and that's going to be where they overlap. What about an or? Well, or is also referred to as a union, okay, and that's where you're going to combine together. And for the and, we use an upside down U, and for the or, we use a U for union there. So we covered this last time, but again, I just want to pick one of each type. We'll do an and we'll do an or, just to kind of review things. So let's go ahead now and look at question 3. And we've got 7x minus 4 is greater than or equal to 17, and 8x plus 7 is greater than or equal to 39. So what are we going to do? So if I gave you this question, and this is something you'll see on your exam, something similar to it. So this is a pretty easy one. Where did we begin? Well, we begin by splitting it in half. We're going to do each one individually, and then we're going to put them on the same number line. So we'll go ahead and work each one of these out individually. So I'm going to begin by adding that 4 over. And that leaves me then with 7x is now greater than or equal to 21. We'll divide by our 7. And so x is greater than or equal to 3. Did we flip the inequality symbol? No. Why not? Did we divide by a negative number? No. Very important. Whenever you divide by a negative, what do you do with the inequality symbol? You flip it. Okay. So let's do the other one. Same process. Move that 7 over. And that gives you then 8x is greater than or equal to 39 minus 7. That's a 32. Divide by your 8. And x is now greater than or equal to 4. Now, this is an and what does it mean if it's an and? All right, and means we look at where they overlap. So we're going to be graphing these on the same graph, and we're going to see where they overlap from. So let's go ahead and do that. Make sure you label them. Also remember, greater than or equal to, less than or equal to, those get square brackets, strictly less than, strictly greater than. Okay, remember those are going to get parentheses. Now, which way it points is which way we shade. So we're going to start off with 3. And on this one, it's pointing to the right. So that is where we'll shade. So we'll shade out to the right. So it's there. What about the other one? Well, the other one is over here at 4, right? And when we look at this one, which way does it point? It also points to the right, doesn't it? Now, where does it overlap at? So we're looking to see where they overlap, where it is in both. And this would be the combination of both. And if you go out to the right, well, that goes out to positive infinity. Okay? So what is this going to look like now in interval notation? Well, in interval notation, this looks like 4 with a square bracket. And where does it go to? It goes to infinity. And infinity always, no matter what, gets parentheses. So that would be your answer on that. Okay. Yes, so we're looking at questions right now out of 1-6, and then we'll look at 1-7. Okay. So we just did question 3. Is everyone okay with how I did that? And we can ask more questions if you need to. Sure, yep, we can add 4 to the list as well. So let's make sure we know how to do question 4. Question 4 is an OR. This one's actually a little bit easier because we're not going to have to solve anything. It's already done. So we're going to put these on a number line. And our first one is 2, and it is pointing to the left. So we're going to shade back to the left, and we're going to use square brackets, aren't we? So that one would look like this. So here's my 2. There's that piece. Does that make sense so far? What about the other one? Okay, well, the other one is over here at 6. And which way does it point? Well, it points to the right. It's greater than or equal to, so we're going to use a square bracket. And how do we now write our answer? Okay, now, if this was an AND, it would have no solution, because they do not overlap at all. But what is this one? This one's an OR, so we combine them together. So what does it look like when we combine these together? Well, it looks like negative infinity, we read it from left to right, comma 2 with square brackets. Now we represent putting them together with a U for union, and the other piece is 6, 2, positive infinity. So because this is an OR, we put the pieces together. We use a U for union. Does that make sense on that? Okay. So we'll now look at question 7, and then we can add more if we need to. We've got plenty of time to work out as many of these as we need to. So let's see what we have here. So this one is an OR. So again, we're going to split it. Do each one separately. So move that 2 over with subtraction. So now we've got 4x is less than or equal to, that 2 moves over, negative 8. We'll divide by our 4. Do we flip the inequality symbol? Yes or no? Are we going to flip the inequality symbol here? No. Why do we not flip the inequality symbol? Okay. Yep, we divided by 4, which is a positive number. So it stays the same. So that is less than or equal to. And negative 8 divided by 4, well, that makes it a negative 2, doesn't it? On the other side, it's very similar. We divide by our 4. And that gives me x is now greater than or equal to negative 1. Is everyone all right with how these work? We put them on the number line. We have an OR, which OR represents, again, that union. And negative 2 is a smaller number, so it's going to go on the left. Negative 1 is on the right. We've got the negative 2, and it is pointing back to the left, so it's going to look like that. What about the other one? The other one's at negative 1, okay, and it's pointing to the right, so it looks like that. If it goes to the right, it's positive infinity. If it goes to the left, it's negative infinity. And what is in between them? 4. What would my answer now be? In interval notation, we take it right off that number line. Negative infinity with parentheses, comma, negative 2 with square bracket. We use a U for union. And then we've got negative 1. And where does it go to? It goes to positive infinity. So does that make more sense now? Are we okay with these? Do we have any more that we need to look at? Any others out of 1, 6 to look at? Sure, yep, we can do 6 as well. Now, 6, we're going to be flipping the inequality symbols because we're going to be dividing by a negative number on one of these. Okay, so same process. And always take your time. Don't ever try to rush through things. Always take your time. So we're going to begin by subtracting off that 1. And that's going to then leave me with the minus 5x is greater than or equal to 10. And we'll divide by our negative 5 here. And that leaves me with, now inequality is going to flip, so we'll flip that around. And that's going to then leave me with a negative 2. I'll be right back. I think we have a student looking for me. Right back. All right. Okay, so let's go ahead and finish this one. Now, when we divided by that negative, that flipped the inequality symbol. We're going to repeat the process over here. So move that negative 3 over. And that gives us 3x is now greater than or equal to a negative 12. We divide by that 3. This time, though, we're not going to flip our inequality symbol because we are dividing by what? We're dividing by a positive 3. So it's the small things that get really frustrating when you make a mistake. So take your time. Don't rush through these. You're a lot better off to take your time and not make mistakes than you are to make mistakes and then have to try to fix them. So take your time with them. Now, this is an OR again. So we put these on our number line. Negative 4 is a smaller number, so it's on the left. Negative 2 is on the right. And this one is negative 2. And this says x is less than or equal to negative 2. So in this case, it's going out in that direction. What about the other one? Okay, the other one's at negative 4. It's pointing to the right. So it's going to shade to the right. Now, what is in between them? Or, What does OR mean? OR means we combine them together. So if I combine them together, what does that do? If I combine them together, that covers the entire line, doesn't it? And so that line would go from negative to positive infinity. So my answer would then be negative infinity to positive infinity. All right. Is everyone okay with that so far? We see how that one's working. So if it covers the entire line, that is all real numbers, and that's negative to positive infinity. Did we have any others out of 1.6 to look at? Does that take care of most of those? Sure, yep, we can look at number 2 as well. Now, number 2 is an AND. And so what does it mean if it's an AND? Okay, an AND means where they overlap. So number 2 is 8 is less than 7x minus 6. And now this one we also have to be careful about where the x is. 8x minus 10 is less than 38. Now, one thing we have to be careful of when we work with these inequalities is we need to make sure that we get the x on the left. It's very, very important that the x is always on the left-hand side. So I'm going to move that 7x over. And we'll do it in 2 steps, that way we don't make a mistake. So then we have minus 7x plus 8 is less than a negative 6. And we'll move that 8 over with subtraction. And that then leaves me with negative 7x, right, is strictly less than. We've got 8 and 6, those go together, and that's going to make that a negative 14. But we always need to make sure that the x is on the left. So move that over first, and then move things around. Now, what do we know? When we divide by the negative 7, well, what is that going to do to my inequality symbol? We divided by a negative 7, so that makes the inequality symbol flip. And negative over negative makes it a positive 2. So there's that piece. Huh? Okay. Why I moved it over, you mean? Okay, I want to make sure that the x is on the left-hand side. So it needs to be on this side. So what I did was, it's positive 7x here, so I took it away from each side so it would be on the left. Are you with me so far? Because this is like an equal sign. And remember, when we solve it, we always make sure that our x is on the left, don't we? So what we want to do is move that x over first. It's very, very important with inequalities. So I move that 7x over first, and then I move the 8 to the right. And then I divide it by my negative 7. Does it make sense now? Yep. Always have to make sure that that x is on the left-hand side. It's over here. Now, what about the other one? Okay. The x is already there, so we've got to move that 10 over. And that gives you then 8x is less than, we've got 38 and 10. That makes it 48. Okay. And then we'll go ahead and divide. Divide by that 8. We're not going to switch our inequality symbols. They'll stay the same. And 48 divided by 8 should be a 6, isn't it? And the inequality symbol stays the same. Are you with me so far there? Now, what about this one? This one is an AND. That means we're looking to see where they overlap. So here's my line. 2 is the smaller number, so it's back to the left. 6 is the larger one, so it's to the right. So this one says x is bigger than 2, so we're going to use parentheses, and it's going to open to the right, or sorry, points to the right, so we'll shade to the right. What about the other one? Okay, the other one, which way does it point? It points the other way, it points to the left, so it's going to be here. Now, what does the and mean? And means overlap. So where do these overlap? They overlap each other right in the middle. So what would my answer look like? In interval notation, it's 2 to 6, and in this case they get parentheses. So does that answer that question? Yeah, and always just take your time. Make sure that x is always on the left. It has to be on the left-hand side. Very, very important. Any others? Does that take care of all those? Okay. What about now 1/7? We didn't cover all of 1/7, but we did the absolute value equalities, right? So we're going to look at a couple of those. Today we're going to be finishing up the inequalities so we can get ready for our test on Thursday. Or sorry, not Thursday. Thursday we'll be reviewing. Test will be on Tuesday. So Thursday we're just going to spend the class period reviewing. So let's now look at 1/7. And I picked some of these out for us to look at. And we can add more to the list if we need to. So we'll begin with question 5. So we've got 4s plus 5 in absolute value equals the absolute value of s plus 6. Now, what do we need with an absolute value? Whenever we solve an absolute value, we're going to get two equations, right? We have to have two equations to get two answers. So let's make sure we can get those two equations. Okay, so we want to get our two equations here. So what are they going to be? Well, the first one, we just simply drop the bars. So we've got 4s plus 5 equals s plus 6. So there's one of them. And we always put the or in between them. What about the other one? Okay, well, what's the other one? The other one, we write it down as 4s plus 5. So the left side stays the same. The right-hand side, remember, we put a negative in front. And use parentheses because you're going to have to distribute it through. I do what now? Okay, because when we solve an absolute value, there's two numbers that'll work. So let's think about 9. How can I get an absolute value of a number to give you 9? Well, the absolute value of 9 is 9, right? And the absolute value of negative 9 is also what? 9. So you're going to get two of them. So the first one is the positive side. So it stays exactly the same. Now the second one, what we do, and we only change the right-hand side, is we take whatever's in here and we put the negative in front. That's going to give you the negative answer because you have a positive one and you have a negative one, right? 9 and negative 9. Now, they might end up being both positive, both negative at the end. That's okay, but you have to have your two equations. So one of them, all you do is drop the bars. That gives you half of it. The other one, you always keep the left-hand side the same, and the right-hand side, you put the negative in front, and we're going to be distributing through. We always put an or between them. Okay, so let's go ahead and finish this out. Move things around and solve it. So we're going to move that s over and move the 5 over. So 4s minus s, 4 minus s, that leaves you then with a 3s. Okay. The 5's cancel, the s's cancel, and 6 minus 5, well 6 minus 5, that's a 1. Divide by our 3, and now we've got our first solution, which is s equals 1/3. So there's the first one. We do not have to graph these. Why not? It's an equal sign. So if it has an inequality, we have to graph it. But this is an equal sign, so we don't have to graph it. So just move things around and was careful with my signs there. Now, what about the other one? All right, well, the other one, we have a negative in front. So the first thing we do is we distribute that negative through. So now we've got 4s plus 5 equals, distributing the negative through, we've got a minus s and a minus 6 there, okay, because both of them get distributed through. That's why I like to draw the arrows, so we remember that. Now, we need to combine like terms, move things around. So I'm going to add s to each side. That's going to move that over. And then I'm also going to move that 5 over. So 4s and another s, that makes it 5s. The 5's cancel here. The s's cancel. Minus 6 minus 5, that makes it minus 11. We'll divide by our 5. And now we've got it, because what's our second answer? S equals a negative 11 what? Negative 11 fifths. And why do we have two answers? Because an absolute value gives you two different numbers. So it'll work. And so what did we do? We took it. First off, we just dropped the bars. So we rewrote it without our bars here. Second one, the left-hand side just came down. The right-hand side, we just put a negative in front. Then we distributed through and solved. Okay. Do we have to graph it? No. Why not? Because this is an equal sign, and we don't have to graph equalities. Looking at another one, this one's a little bit different. We're going to talk about question 10. And this is a very easy question. And this is something that I like to put on the exam. So this is a question that's an easy question. It just makes sure that we understand absolute values. So let's take a moment to think about absolute values. So what happens if I take the absolute value of 9? Okay, that's 9. What about the absolute value of negative 12? Well, the absolute value of negative 12 is a positive 12. Okay? What about the absolute value of a negative 100? Well, that comes out to be a positive 100, right? So every time, whenever we take an absolute value, it always comes out to be what? Positive or 0, right? Because the absolute value of 0 is 0. Well, what is this one saying? This one is saying the absolute value of a number is negative 15. And can that happen at all? No, right? Because every time I take an absolute value, okay, look at these. That's 100, right? Absolute value of 5. Well, that's 5. Absolute value of negative 25, what is that? Right. And if it's equaling a negative, that can't happen. So that can't happen, so then this actually has what? No solution. And we represent that with the empty set. So whenever it comes out to be a negative number, you do not have to solve it. It's going to be, on these equations, no solution. So here's another example. And I can even make it look really complicated, but it's still going to be very easy and have no solution. So let's look at this one. How about 3x plus 4 equals negative 10? Now, do I have to solve this one at all? No. Why not? This is negative, right? And if it's negative, it can't happen. And that means it has what? No solution. So we don't have to solve it. Just by looking at it, right? Whenever you have a negative number on the right-hand side, and it's an equal sign, it has no solution. And we'll talk about the inequalities today. But does that make sense on that? So always look to make sure first that it's positive. If it's negative, you don't have to do any work. Right? It's done. So that's why I picked that one, just to reinforce that concept. And that's something I like to put on an exam. It's one very, very simple like that. Let's try another one. 15, I put 15 on because 15, sure, yeah, we'll go ahead and do 9, then we'll do 15. Okay. So 9 is 1 plus 1/8x equals 2. So what do we know about this one? Is this one going to be solvable? Yes. Why? Because that 2 is a positive number. So that's the first thing I do is make sure it's solvable. Now, what do my two equations look like? Well, we drop the bars, so we have 1 plus 1/8x equals 2, or what about the other one? 1, we just drop the bars again, plus 1/8x, and we change the sign on the right to be a -2. So there's our two equations. So we know we've got two equations, and that has a positive 2 there, so it can be solved. Now, solve it. So what do? Well, I like to get rid of the fractions. So the only fraction we have is an 8. So I'm going to multiply all of this by an 8. So just multiply them both by an 8. And that'll get rid of those. So we'll just do them both together. So that leaves me then with 8 times 1 is an 8. Those cancel. That leaves you with an x. 8 times 2. Well, 8 times 2, that's a 16. The other side is going to be 8. And then we've got a plus x again. 8 times a -2. Well, that's a -16. So all we did was we just distributed that 8 through. That cleared out my fractions. Now let's finish it out. So move that 8 over, and that leaves you then with 16 minus 8. So that leaves you with x equaling 8 here. And what about the other one? Well, the other one, we move our 8 over, and that leaves you with x equaling now a -24. Is everyone okay with that so far? So now let's move on, and we'll look at 15, and then we'll talk about inequalities. So for 15, we have the absolute value of 1/3 x plus 1/3 plus 1/4 equals 5/4. If I was going to solve this one, I wouldn't clear out the fractions because they're going to be easy to work with. Because what do you know about these? Well, these have the same denominators, don't they? So I can just move that over. So I'm going to subtract off 1/4 from each side. And if you have trouble with fractions, you can do that over here. So 5/4 minus 1/4. These have the same denominators. And 5 minus 1, that makes it a 4. Denominators are the same, so that's a 4. And 4 over 4 reduces down to a 1. Okay, so this is going to reduce down here to a 1. So the first thing that we always do is make sure that that x, or sorry, not that x, but that absolute value is by itself on the left. So move everything else to the right. And that's what that's going to look like. Now we can solve it. Okay, we're going to get two solutions. So what are the equations going to be to give us our two solutions? Well, it's 1/3 x plus 1/3 equals 1, or 1/3 x plus 1/3 equals a -1, right? Exact same equations. What's the only difference? All right, well, the only difference is that one of them is positive on the left, or sorry, on the right. The other one is negative on the right. Now we can finish this. I would clear out my fraction, so I'm going to multiply these by 3. So we'll just distribute that 3 through. And let's see what we get here. So when I distribute that 3 through, that cancels, and that leaves you with an x. Cancels, that leaves you with a 1. Always be careful. Watch the arrows. 3 times 1 is a 3. Move that 1 over. And so our first solution is x equals 2. Repeating the process on the other equation, we get an x, a plus 1, and 3 times a -1, well, that is a -3. We'll move that 1 over, and so now we've got x equals a -4. So does that take care of those questions? So what we're going to be looking at today is we're going to be looking at absolute value inequalities. So these were equalities, right? And we didn't have to graph them. The ones we're going to be looking at today, we're going to have to be graphing them on a number line. So I'm going to show you these pictures from our textbook here. We're going to talk about how we graph the different ones. And this is, by the way, on page 126. They have you do it a little bit differently than I do. I just want you to focus on the graphs. So if your absolute value looks like this, where it points, and I always look at it as easy as possible, if it points to the right, you shade to the right and you shade to the left. So it looks like that. If it points to the left, it's in the middle. So that's all we really need to remember. So I'll write it down so that we have it. And again, this is 1.7. So if it looks like this, looks like an absolute value. We'll just go with the first one here. If it points to the right, your answer will look like this. Okay, so if it points to the right, it looks like that. If it looks like this, absolute value of ax plus b is less than your k, your answer will look like this. So that's all we really need to remember. The textbook has you do it a little bit differently, but what we're going to be doing is we're going to be getting the numbers, and then we either shade on the ends or we shade inside, one or the other. So if it points to the right, you shade to the right, you shade to the left. If it points to the left, we shade in the middle. We're going to go through several of these. It's basically what we have just done. We're just going to add on another step. So we're going to start off with a really easy one here. So the first thing I'm going to do is I'm going to look at the way that it points. Okay, so which way does it point? It is pointing to the left. Okay, so what is my answer going to look like? Well, we'll have brackets here. So it's going to be shaded in the middle. So that tells me that if it points to the left, you shade in the middle. If it points to the right, you shade on the outside edges. So this one points to the left, so we're going to be shading in the middle. Now, why does it have square brackets? Well, remember, greater than or equal to, less than or equal to, those get your brackets. Strictly less than, strictly greater than, well, those are going to have what? Those are going to have parentheses, right? Okay. We're going to solve it the same way that we've solved the others. Nothing new. So what do my two equations look like? They look like x minus 5 equals 9, or x minus 5 equals what? Negative 9. Nothing new. It's all exactly the same. Move that 5 over. And so now we've got x equals, now we've got 14. Move that 5 over. And we've got x equals now negative 4. Okay, so that's what we've got so far. Now, what are we going to do? We're going to put these on the number line because this is an inequality, right? So these go on our number line here. And negative 4 is on the left. Positive 14 is on the right. And what is it going to look like? Which way did this point? This pointed to the left, didn't it? That means it's going to look like this. So what does our answer look like? We don't have to do anything else, but just compare. So it looks like it's going to be shaded where? In the middle. And what does our answer look like now in interval notation? Well, in interval notation, it looks like negative 4 to positive 14. So it's all about looking at which way it goes, which way it points. There's other ways of doing these, but I think it's easier if you just remember, okay, if it points to the left, you've got to shade to the left. If it points to the right, you shade in the middle. So let's try another one. A little bit more complicated here. We did that one last time. Let's do it the other way. Let's do it the other way. Let's make it greater than. So let's make sure it's greater than. So make sure it's greater than there. Because we did less than last time. Let's do it greater than this time. So what's the first thing I need to do? Okay, here's where students make a mistake. Before I do anything else, before I start solving it or anything, the first thing I have to do is move that 9 over. So before you do anything else, we have to make sure that that absolute value is by itself on the left. So before anything else is done, you have to make sure absolute value is by itself on the left. Now, which way does this one point? This points back to the left. Or sorry, points to the right, doesn't it? It points to the right, so which way do we shade? It points to the right, so that means our answer is going to look like what? That. Okay. Why does it look like that? Because if we go back and look, okay, if it points to the right, which way do we shade? The way I remember, if it points to the right, you shade to the right and shade to the left. So I just remember, right gives me the right. If it points to the left, shade the middle. So just remember, left gives you the middle. So this one is pointing to the right, so I shade to the right and to the left. Now, what are my two numbers going to be? Well, let's find them. We've got 3x plus 5 equals 11. And what's my other one going to be? 3x plus 5 equals what? Negative 11. Now we'll go ahead and finish this. So move that 5 over for each one. We'll do the left equation first. So that is then 3x equals, we've got 11 minus 5. Well, 11 minus 5, that's a 6. We'll divide by our 3. So x now equals, it looks like 2, doesn't it? Other side, move that 5 over. So 3x now equals a negative 16. We'll divide by our 3. So x now equals a negative 16 over what? 3. Okay, now, what is it supposed to look like? This. Make sure that you put them in the right order. Okay, so we know that my answer needs to look like this. Which one's smaller? Well, minus 16 over 3 is smaller. Positive 2 is a larger one. Because it is a greater than, it's just greater than, not greater than or equal to. Because it's greater than, we use parentheses. So my parentheses go here and here. Okay, and then we shade. And what does it look like? Well, it's negative infinity to positive infinity. And what does the answer look like now? We've done these before. Putting these together, my answer would be negative infinity, comma, negative 16 over 3, parentheses u for union, 2 to infinity. Okay, so there is my answer. We'll do a couple more just to make sure we know how to graph these. And then we'll look at some of the special cases that have either no solution or an infinite number of solutions. So let's look at a couple more. So let's look at this one. Again, pretty easy to solve. So what do we need to do? First thing we always must do is what? We must move that 9 over. Because the absolute value has to be by itself. Minus 4 plus 9, well, that leaves you with a 5, doesn't it? Which way does it point? It points to the left. So since it points to the left, that means we shade the middle. So it's going to look like that when we're done, right? Points to the left, shade in the middle. Points to the right, okay, shade on the edges. Okay, so let's now go ahead and finish this out. Okay, and you're for my college algebra exam, right? Yep. Okay, let me get you started here. Just take them out, so they're right back. Grab the exams real quick. If you will just follow me. Real quick here. Get you started. Sure. I do what now? Would you rather do it at 1:30? Yep, we can do it at 1:30 then. Okay, yep, that'll work. I'll be in my office at 1:30. I got someone else coming in at 1:30, so that'll work too. Okay? You're welcome. Okay. So let's go ahead now and finish this one out. So we saw that it shades to the left, pointed to the left, so we shade in the middle. So what do? We first have to get our two equations. So we have a minus 4x plus 2 equals 5, or a minus 4x plus 2 equals a what? Negative 5. Okay, we're going to go ahead and finish it. So we'll move that 2 over. And now we've got minus 4x equals 5 minus 2, that makes it a 3. We'll divide by our negative 4. And that leaves me now with x equaling a negative 3/4. So there's one of them. What about the other one? Move that 2 over. And now we've got a minus 4x equals a minus 7. Divide by that negative 4. And that leaves you now with a positive 7/4. Okay. All right. Put this on our number line. We have now a negative 3/4. We have a positive 7/4. And which way does it point? Points to the left, so where do we shade? Shade in the middle. Okay. Always look at which way it points. Brackets or parentheses. This one is a less than or equal to, so that means we're going to be using square brackets. So there's our answer in the middle. What does this look like now in terms of interval notation? In terms of interval notation, it's minus 3/4 with the square bracket, comma 7/4, also with the square bracket. Okay, so there's my answer. I'll be right back. I've just got to go check on a tester real quick, so take a short break. We'll be back in like 2 minutes or less, probably like a minute. I'll have to just walk down the hall. We'll come back. We'll try it out. So just give me one moment. I'll be right back. We'll go ahead now, do a couple more. And that'll be it for today. So we have a couple more to look at. So we've seen how to solve these when they're a positive number, but when they're a negative number, it's either going to have no solution or an infinite number of solutions. These are very easy to do. So let's look at this one first. Okay, so make sure you pay attention for this one. This is very easy. These appear on your exam. So first off, whenever it's a negative on the right-hand side, we do not have to solve it. It is either going to have, and it's very important that you pay attention for this part. This is where students always make a mistake. It's very easy to make a mistake on these. Just like we did with the equations. Okay? When it was equal to a negative number, that couldn't happen. Now, if it's an inequality, it's either going to be true, meaning everything, or false, meaning nothing. So since this is negative, it's either true or it's false. And what we do is we think about an absolute value. And an absolute value is going to give you out a positive number. Are positive numbers smaller than negative 5? Are positive numbers smaller than negative 5? True or false? Positive numbers are bigger, right? This is saying that they're smaller. So this would be then what? False. Okay? And if it's false, it has no solution. So since it's negative on the right-hand side, it's either true or false, meaning everything or nothing. I like to put these on the exam because they make sure you understand the concepts. Let's do another one. We'll probably do 3 of these. There's nothing to these. Let's look at this one. What do we know? That's a negative 9, right? So, since it's negative, it's either true or it's false. Now, what do we know about absolute values? All right, absolute values give you out positive numbers. So it's very simple here. We don't have to solve anything. Are positive numbers bigger than a negative 9? Positive numbers bigger than negative 9? Yes, they are. So that will make this then what? True. Okay, and if it's true, what's your answer? Negative to positive infinity. We'll look at one more. Talk about a couple of homework questions, and that'll be it for today. So you'll be getting out a few minutes early. You'll probably get out about 10 minutes early. We've got a couple more questions to look at here. So let's say I give you this one. And again, solve it. So what do we know about this one? What do we know about absolute values? Okay, absolute values are either positive or 0. So, our positive numbers now, our positive numbers, are they less than 0 all the time? Are positive numbers less than 0? True or false? That would be what? False. So that means that this one has what? No solution. Okay. And on a number line, what would the number line look like? It would look like that, nothing on it. It would be a blank number line, no solution. There's one in your homework just like it, question 13, basically the same. Now I do want to look at a couple of questions from your homework, and these all work out just because I do want you to refer to the textbook once in a while. Okay, so let's look at question 8. So this is 1.7, and these are from your homework. And I do sometimes work out homework questions in class. And I give you this one. So the absolute value of ax plus b equals k if k is less than 0. So how would I work this one out? What does it mean? If I give you this, what is it wanting you to do? It wants you to tell me the number of solutions. So what does it tell you about k? It says that k is less than 0, right? So it's less than 0. So let's pick a number that's less than 0. Let's use, how about k equals minus 4. Minus 4 is less than 0. Now, we've talked about this one before. K's got to be less than 0, so I can pick any number that's less than 0. So I said -4. Now, tell me, absolute value equals -4. Is that true or is that false? We've covered this before. We talked about it earlier today. True or false? Well, can you ever get a negative number out of an absolute value? Let's think about absolute values. -4. What's the absolute value of -4? +4. What's the absolute value of 5? +5. They're always positive, right? Can positive numbers ever equal a -4? No. So that would make this then what? False. So this one would have no solution. Okay? Because we picked a number that made it work. So in this case, we used a -4. And that gave us then no solution. So I want to look at that one. And then there's one more. I also want us to look at 12, and I'm going to leave 13 for you to do. Okay, so on question 12, this is nothing but using the textbook. So all you need to do is look in your textbook. And we're going to look at our choices. And we're going to see which one it is. So this is non-calculational. Okay, we're going to go to our textbook. So we're going to use page 126. Now, on page 126, okay, let's look at these two. And I want you to look at the equations here that are below, the inequalities. If it points to the right, that means we have these two inequalities separated by an or. If it points to the left, it's in between the two. Now notice this one is absolute value. AX plus B is greater than K. So we solve it. AX plus B is greater than K, or AX plus B is less than a -K. If it's the opposite way, then it's in between. Now, what do we have? Let's look here at question 12. If we look at question 12, which way does it point? If we look at it, it points what? Okay, it points to the left. So what does it need to look like? That in the middle. So which ones can we get rid of? It needs to look like this part right here. This is on page 126. So which ones can we get rid of? It's definitely not A. Okay? It's definitely not D. That doesn't make sense. So it's either B or C. Now look at the way the inequalities go. They both open. They always open to the right here. So which one does it look like now? It looks like it has to be what? This one doesn't work, because notice they're going in different directions. So that one doesn't work. What's the answer then have to be? B. So the answer for 12 is going to be B. 14 is very, very similar. It's just that it's flipped around. So the answer for 12 is going to be B. And you'll use that table on page 126. You'll also use it for 14. So 14 is the same as 12, and you want to use page 126. So that's going to finish up the lecture for today. I'm going to go ahead and pass out the sign-in sheet. Graded homework is over there. If you have any homework you want me to grade, be sure and give that to me today, and I'll get it graded for you.